Hello everyone, I welcome you to the channel Electrical Science by Dr. Sanjay Upreti. So in today video, I am going to discuss a problem of a transformer efficiency. So uh, this question was asked in a recent examinations of a IP University in a paper of in the paper of electrical science. So in this question, it was given that the transformer rating is given. A transformer is rated at the 100 kVA. At full load, its copper loss is 1400 watts, and the iron loss is given at the 940 watts. So you are asked to compute the efficiency at the full load and unity power factor, efficiency at the half load and the same power factor means unity power factor, and the load kVA at which the maximum efficiency will occur. So in this question, so let me let us first understand what are the losses in the transformer, right? So let me draw a transformer here. So I am drawing a transformer here. So this transformer, so this is the primary of a transformer where the electrical source is connected here, and this is a secondary of transformer, and in this secondary of a transformer the load is connected always, right? So this is a load here, load, and this is V1. V1 of a source voltage is V1, and here you can say the voltage is at the secondary side it is V2, and the current here is the I2. Similarly, the current here is the I1, right? So in the transformer you can see, so these are the two windings are there. This is a primary winding, this is a secondary winding. So these are the windings of a transformer, windings, and this is the core of a transformer. This is a magnetic material. So this core is made up of a iron, and these windings are made up of a copper. So that is why the losses which are happening in a core, they are called the core loss, or the, because core is made up of iron, so that is why they are called the iron loss, right? Or they are also called the core loss, and sometimes it is they are also called the no load loss, right? So why this is called the no load loss or the core loss? So because this core is made up of a iron, so that is why this is called the losses which are occurring at the iron part, they are called the iron losses. They are also the core losses because this is a magnetic core of a transformer, and no load losses. Basically, if you even these losses occur when even the transformer is not loaded, right? So they happen and they remain the constant throughout. They start at the no load, and no matter how much transformer is loaded, so these core losses remain the same. Similarly, in the winding, they are made up of a copper, right? So they are called the copper losses. Okay, copper losses, copper losses. Similarly, they are also called the load loss, load loss. Okay. They are happening at the when the transformer is not loaded, so it means the copper loss will be zero, right? Like they are the constant, but it will be zero, and they will be maximum at the full load. Okay. When the transformer is fully loaded, the copper, because they are happening because of the loading of a transformer, so that is why they are also called the load losses, or they are happening in the copper part of a transformer, so they are called the copper losses. So we are given here the 1400 watts to PC. Let me write this one as a PC copper loss at the full load. PC at the full load, it is given as a 1400 watt, right. Similarly, Pi, that is iron loss, they are constant, so no need to write at the FL or no load. So they are this is equal to the 940 watt, right. Because transformer is rated at the 100 kVA, so let me change all these units to the kVA. So let me change this PCFL is equal to into kilowatt, so that will become 1.4 kilowatt. Similarly, the Pi will become 0.94 watt, right. The efficiency of a transformer given as or any electrical equipment is given as a P out, output power, divided by input power, PO divided by P in. Similarly, that PO divided by P in can be written here as a PO, that is output power, plus losses. So losses here are the PC and PI. This is the definition of efficiency. And there is some another formula which is written for this one. So PO can be given by as a PO is equal to, let me write it here. So PO is equal to V2 into I2 into cos phi. That is the V2 into I2 and the power factor of this one. So this is called as a PO, right. So here we need not to know about the V2 or I2 because the transformer kVA rating is given. So efficiency at the full load will become N is equal to, that is the 100 kVA and power factor is unity. So PO will be equal to the 100 kVA multiplied by 1, or it is 100 kilowatt, and it will be divided by, it is 100 plus PC is given here as a 1.4, right, and it is given as a 0.94, or it will become, if you add all these two, so it will become 100 divided by 100 2 into 34, or if you calculate this one, so that comes as a 0.9771, or so percentage efficiency will be equal to the 97.71%. Okay, so that is our first answer here. It is 97.7%, right. So answer for the first part is equal to 97.71%. Now let us go to the second part. For the second part, efficiency at the half load at the same power factor, right. So the frequency, the formula will be, let me write this one. So N will be same, right, that is PO divided by PO plus PC plus PI, ठीक है. So at half load, PC will be changed, PI will remain same, right, but PC will change, right, and PO is given unity power factor, so it will become 50 kVA divided multiplied by 1, so PO can be find out. Only question is that how much copper loss will be there, will occur at the half load. So the copper losses, as we know that these copper losses are happening in a copper part, right. So in a copper part, so this load losses or the losses in the resistance, they are always given as a I square into R. Okay, these are the ohmic losses, we can say ohmic losses. So and second part in this one, the transformer, this transformer which is rated as a 100 kVA. So transformer rating is given in a kVA, and its voltage always remain constant. Voltage is a constant here. So VA is equal to voltage multiplied by current. ठीक है, तो kVA will be so that is VA, if you multiply it by both sides by the 1000, so it will become kVA. So voltage will remain the constant of a transformer irrespective of their loading, but the only loading changing means you change the current. If you increase the current, increase the load, the current will increase, or it otherwise current will decrease. So at the half load, how much current will decrease, and the losses PC is directly proportional to the I square, right? So with these two information, we will try to calculate this one. So at the half load means VA will become, so VA at half load, at half load, okay, at half load, let us say current is IHL, I into HL. At half load, the current is VHL. So at the half load, current is IHL. So V multiplied by IHL. Okay. It will become, because power factor unit is given, so it will become is equal to 50. That will become 100. 50% means 50% of the 100, so it will become 50 kVA, 50 kVA, right? और यहाँ पे मैं इसको 1000 से भी मल्टीप्लाइड कर देता हूँ, 1000 मल्टीप्लाइड बाई V मल्टीप्लाइड बाई IHL, ठीक है, IHL. तो it is, let us say current at the IHL is the current at the half load is the IHL, it will become, or we know that the 1000 into V into IFL is equal to 100 kVA, that is 100 kVA. At the full load it is 100. If you divide these two, right, if you divide this by this equation, so it will become IHL divided by IFL, right, because all things are the constant. It will become 50 divided by 100, or it will become 1 by 2. So it means whenever you are loading 50% loading at the half load, so this current will become half, because voltage is the constant, so current will become half, and current is directly proportional to the I square, ठीक है, copper losses are proportional to the I square. So तो PC at the half load will be equal to the IHL square multiplied by R, ठीक है, और IHL can be given as a IFL divided by 2 whole square multiplied by R, right? So IFL square into R divided by 4, or IFL square into R is given as a 1400 watt, because we know that these are the IFL square multiplied by R. It is nothing but a copper loss at the full load. So at the half load they will be 1 by 4, or it will become 350 watt, or it will become 0.35 kilowatt, ठीक है. Now we know that this copper loss, we know copper loss at the half load, we know Pi is constant, Po is there, so we can calculate this is very easily at the efficiency. So let me first, right, so N will become, N at the HL will become PO is the 50 multiplied by 1, because power factor is 1, so divided by 50 multiplied by 1, ठीक है, और plus PC is coming as a 350 watt or 0.35 kilowatt, 35, plus iron loss will remain same 0.94, so it will become 50 divided by 50 plus 1.29, or it will become 50 divided by 51 plus 0.29, or if you calculate this one, so this will be equal to the let me calculate this one, just a moment. It is 0.9748, or it will become efficiency at the half load will become, percentage efficiency will become 97.48%. So at the half frequency, so let me write here, the second part here is the 97.48%, right? So we have calculated the two efficiencies, full load and the half load. Now we are coming to the third part. The third part here is the load kVA at which the maximum efficiency will occur. So the condition for the maximum efficiency for the transformer is, okay, the condition for N max is equal to is PC is equal to PI. That is the condition, right? So when the copper loss and iron losses are same, so then the condition transformer efficiency will be maximum. So we have to find out the load kVA. We have to calculate the load kVA at which load, right? At 50% it became 50 kVA. Similarly, now we have to find the what kVA it will be there. So PC is equal to PI. So PC will be equal to, PI is constant, it is given as a 940 watt. So it is equal to the 940 watt, right? So let me write this one, PC at maximum efficiency. Maximum efficiency is equal to 940 watt. Okay. PC at the full load, it is given as a 1400 watt. Okay. So divide these two. Okay. PC divided by PC max N and PC FL is equal to 940 divided by 1400, right? So what value of this one will be equal to the, is equal to 0.6714, right? So now PCMA, suppose the current at this maximum efficiency is equal to the say IC. This will become that, let us say that is the I at the N max, maximum efficiency, right? N max, or yeah, max N, or anyway, let me say this is the I N max at the maximum efficiency. Current is there, so it will be equal to multiplied by square into multiplied by R, divided by, that is I FL square multiplied by R is equal to 0.6714, right? So this will get cancelled with R, will get cancelled with the R1. So it is equal to the I N max square divided by I FL square is equal to 0.6714. So I N max divided by I FL whole square is equal to root square of 0.6714, right? So value of the I IN max divided by IFL is equal to, if you calculate the square root of this one, 0.6714. So it is coming as a 0.8194. It is approximately coming average. So what is the meaning of this one, 0.8194? It means the current is the 0.8194 times of the full load current. Okay? The current IN max is equal to 0.8194 times of the IFL. ठीक है, तो इसका मतलब, तो it means the, because the voltage is the constant, so what will be the value of the VA? Value of the VA, if you multiply both side by the voltage, right? V multiplied by I N max and multiplied by 1000 here is equal to 1000 multiplied by 0.8194 multiplied by V multiplied by IFL. ठीक है, so this VFIL, it is nothing but a at the full load kVA rating of the this one, so it is equal to the, so kVA, this will become kVA at the N max. It will become, so it will, this is the kVA of the full load, so it will become 0.8194 multiplied by 100. This is given as a 100. This is that rated kVA of the transformer is 100. So this kVA at the maximum efficiency will be 81.94 kVA. Okay. So that is the answer of the third part. Is the third part, the kVA will be 81.94. 81.94. Now let us third part. It is not asked even what will be the maximum efficiency, but let us calculate the maximum efficiency also. So for calculating the maximum efficiency, so it will be it is equal to N maxi will be equal to the, so 81.94, that is the kVA. Let us assume it is the unity power factor. So 81.94 plus 0.94, because this is the PC or PI will be again 94. So if you calculate this one, so it will become 81.94 divided by summation of this will become 83.82. So efficiency is coming here as a 0.9775, right? So N percentage N max will be equal to 97.75%. So it will be third part. The maximum efficiency will be 97.75%. It is basically, you can see that this efficiency is the maximum. It is 97.71 was coming at the 1400 watt. So maximum efficiency, although the difference is very, the efficiency are quite similar. There is not a lot difference, because the kVA at the maximum efficiency is very closer. It is around 80%. So there is a little difference in a efficiency. So with that, we are concluding that video. I think this has become somewhat long, but it will give you the clear concept of a transformer efficiency, right? So thank you for watching, and if you like this video, please hit the like button. And subscribe to the channel. And if you want to ask any problem related to the electrical engineering, so then you can comment on my the video, so that I can solve it for you. Thank you. Thanks again for watching.